Good day, ma'am. I am Ryan Britt Elsinfran. I am here to present my video presentation and mathematics in a modern world. Fibonacci sequence and the golden ratio. Fibonacci sequence in mathematics. Fibonacci sequence is a sequence in which each number is the sum of the two preceding ones. Numbers are parts of the Fibonacci sequence are known as Fibonacci numbers, commonly denoted as Fn. The sequence commonly starts from 0 and 1, although some authors starts the sequence from 1 and 1, or sometimes from 1 and 2. Starting from 0 and 1, the sequence begins. As you can see on the screen, there is a Fibonacci numbers, which is added by 0 plus 1 equals 1, and 1 plus 2 equals 3, and 3 plus 5 equals 8, and 8 plus 5 equals 13, and so on. Okay, let's proceed to the next line. As you can see in this picture, this is the great example of the Fibonacci spiral. This is a special spiral, a similar curve which keep its shape at all scales. If you imagine it's expiringly out forever, it is called equiangular because radial line from the center makes always the same angle to the curve. Fibonacci numbers are also strongly related to the golden ratio. Beneath formula express the 9 and Fibonacci numbers in terms of n, and the golden ratio that implies that the ratio of the two consecutive Fibonacci numbers tends to the golden ratio of n increases. Fibonacci numbers are also closely related to locus numbers, which obey the same recurrence relation and with the Fibonacci numbers from the complementary pairs of locus sequence. Let's proceed to the golden ratio. Sunflowers provide a great example of these spirally patterns. In some cases, the seeds heads are so tightly packed that total numbers can get quite high, as many as 144 or more. And when counting this spiral, the total tends to match as Fibonacci numbers. This is the formula of the golden ratio. The golden ratio is an irrational numbers 1.618 that emanates from the Fibonacci sequence. Aesthetically pleasing structures and human faces have a golden ratio of 1 and 1.1618 by Tanakov, Jovan, and Melan. In nature, the golden ratio is a distinct relation represented by P by Hennen 243. And also, the numbers of the petals of the flowers constantly followed the Fibonacci sequence. Famous examples include the lily, which has 3 petals, buttercups, which have a 5 pictured at left, the chicory 21, and the Daisy 34. P appears in petals on accounts on the ideal packing arrangement as selected by the Darwin-Waynian processes. Each petal is placed at 0.61, 80, and 34 per turn out of 360 degrees circles, allowing from the best possible exposure to sunlight and other factors.